Hi, this is Dr. G. Bailey. In this video, we're going to go over some IB past papers focusing on multiple choice for the topic of 5.1, which is all about evidence of evolution. So the most important thing when we start with these questions is please read the question 3 times. First, get your anxiety out of the way. Second, try to remember what the content is about. And third, really focus what exactly is this question asking about. Another thing is make sure to read the few options, because sometimes you might see that A and B are so close to each other, and sometimes by 1 or 2 words you might get the wrong answer. So it's very important that you read of all of them and cancel all the possibilities. So now with that a little bit of hint, let's go ahead and read this question. Here says the lichens are returning to the forest of the industrial areas of the United Kingdom due to strict pollution control. So that means the lichens here are basically trying to reduce pollution, right? So he's trying to reduce pollution. He says here, what is the expected outcome in the population of peppered moths? Now, here is where you have to know this from the background, that if you have a white trunk of a tree that is white, then most likely in this white tree, we're going to have all the black moths be eaten. And the white moths, what they're going to do, you're going to increase the amount of white moths. However, in the pollution area, you're going to have the trunks being all black. And when the trunks are all black, what are you going to have? You're most likely to have all the white moths appearing, and that means the white moths are going to be eaten, and that will lead for the black moths to be rising. So in this case, we're saying that the lichen is coming in to reduce pollution. If you're reducing pollutions, that means you're going from a black tree to become a white tree. Right, we talk about the trunk. So what's going to happen here? This means that there's going to be more increase of the black, or is going to be more increase of the white moth. Obviously, it's going to be, if you go back to this scenario, you're going to see there's going to be a rise in the white moths. Why? Because they're going to be hidden in the white trunk. So looking at the options we have here, increase in number in light colored peppered moths. That seems like the answer, but I still will read the rest. Increase industrial melanism in peppered moth. It's not melanism. We are definitely not making them black. Increase predation of peppered moth. Now, it does not necessarily increase the predation of peppered moth. In increased predation moth, it has to be more specific. I would still say, oh, this could be possible, but it's basically needs to be more specific. This needs to be said that it's black. Increase the speciation of peppered moth. Not necessarily, because we already had the white before. So the one that is more specific is this. It's A, because it gets you a little bit more detail by saying the light colored, when this one is only saying the predation of peppered moth, but it did not mention black. So even though C could be possible, the answer, it's not specific. So A is the answer. Next, which evidence for evolution due to the common feature in the bone structure of the vertebral limbs provide? So in this case, we are talking about where they have the structure that is the same, right? Because it says common feature. Common feature here means trait. And we talk about the bones structure. So this most likely we're talking about the homologous. And when we talk about the homologous, they have the same structure, but they have different functions. So in this case, they must have a common ancestor. If this ancestor had the same kind of bones, but then with time, they came out to have different functions. So in this case, we are talking about adaptive radiation. Why is that? Because the word radiation, that means it's spreading out, and adapt, that means adapting to the environment that they are, right? Whatever the environment that they are, you'll make one swim, one walk, one run, and whatever it is. So the right answer for this will be the adaptive radiation right here. It will be A. Now, some students are going to say, well, but it couldn't be divergent. Well, divergent would have been more in the case of a mutation. Yes, it's just like this, but there's mutation going on. Conversion, it would have been the opposite. It would have been that many species, they come together to become one species. And this continuous variation would be the same thing as this, where many species become one species. So the only answer is A. Remember that adaptive and divergence, one difference is mutation for divergent, and adaptive has to do more the environment changing the scenario for them. So moving on to the next question here. The next question says, the graph shows a song duration of birds from the genus Phylloskopus samples from the west to east throughout the northern Europe and northern Asia. Okay, so we're talking about the songs. So we have here the east and the west, and we have samples of locations, and then we have the song durations. So here we have, as we look in the signs, we can see some songs are 2 minutes, some are 3, and there are some that are 4, between 4.5 or 4. So there we're looking at different ones. Now, the question says here, what concept do these data illustrate? Is it gradual divergence? Is it adaptive radiation? Is it interbreeding population, or is it punctuated equilibrium? So this is where we have to figure out which one of these answers are. If we're talking about gradual divergence, you can see that there is a change gradually, right, as it moves along. And what I mean by that is that there are different species. You're going from the west, and then with time, they're gradually having a better, strong singing. If it was adaptive radiation, it wouldn't have this gradual one, right? It would just be a spread going this way. It has nothing to do with interbreeder populations. It has nothing to do with punctuated equilibrium. Punctuated equilibrium would just cut, and then you will have a completely new one coming in. So of all of this, the fact that it's gradually changing in the way it sings to complete new species, that is where we're going to say that it's a gradual diversion. So in this case, it would have been A. Now, in this question here, it says, which of these structures is not homologous? That means they're not the same. You can easily see that these all have the bones, and they have the red section, and they have the yellow. But this one doesn't. So the homologous means they have to have the same structure. So C is the answer. It does not have it. Now, moving on. We have here about green lizards, Lacerta trilineata, living in the mainland Greece, and it eats mostly insects, but it also small amounts of plants. So it eats insects and plants. The same species living on a Greek island where insects are scarce, which that means scarce here means that it doesn't have it, show a greater percentage of those physical traits useful for eating plants than the mainland lizards. So basically they're saying there's this one lizard here, right, that eats insect as well as plant. And he's in one island. Now they're saying there's another island in which it's a lizard that looks a lot like the other one, but in this one, he only is eating, he's eating only plants. And the reason why is because there is not much insect, okay? So the question says, what is the biological explanation for this observation? So basically they're saying that the lizard here in this island was able to eat insect and plants. And then in this island, the lizard somehow only had the feature that makes them eat plants, but he doesn't have, that means he doesn't have traits that eats insect. So somehow he was adapting to the new environment. That's what he was doing. So this would be more like an adaptive radiation. So let's look at what the answers we have here. A variation in each lizard population allow adaptation to occur. Lizards migrated to areas where they were better adapted. Lizards on the island diverged due to lack of interbreeding with the mainland population. Homolog structures have prevented separated species from evolving. Now, we read all this, and here is what I usually see students more thinking. First, they will cancel the homologous structures because it has nothing to, homologous has nothing to do with separating species from evolving. This has nothing to do with that. Let's see, variation in each lizard population allow adaptation to occur. When it says here variation of each lizard population allowed their adaptation to occur, this is saying that there was a mutation. And here we didn't say a mutation. The whole story did not say about mutation. The story said about a food not being there, right? That means we didn't have insect. Insect was not there, so it has nothing to do with mutation, so A is out. The lizard migrated to areas where they were better adapted. It doesn't make sense. Here they can eat 2 foods, and here it can eat only 1 food. So how is that a better adapted? Then that's a no. And then here it says lizards on the island diverged to lack of interbreeding with the mainland population. So that makes more sense. They will leave this area, go to another place because they couldn't reproduce, and here they eventually turn to just plants because that's what they could eat. So the answer would be C. So moving on to the next question, it says here, what process best explains the formation of different pentadactyl limbs? So this we're talking about where does pentadactyl limb comes from. Now, if you have studied this, we are talking about homologous structure once more time. And we know the homologous structures means that they have the same structure, right? And they're coming from a common ancestors. And so the common ancestor eventually will lead to different species, right? Species 1, species 2, species 3. Now, this is an example of adaptive radiation simply because the environment that they were exposed are so different it caused them to change themselves. So basically, pentadactyl is an adaptive radiation. So it's not interbreeding. It has nothing to do with them crossing with each other. It's not that we are choosing traits, and it's not convergence because that means all the pentadactyls will come together from ancestors. So adaptive radiation is an example of, pentadactyls is an example of adaptive radiation. So the answer is A. If you study the first lecture that I have, you will see the pentadactyl is an example of adaptive radiation, and that's an easy answer to do. Now, moving on, this question says, which is an example of speciation? Now, speciation is basically you create a new species. So let's look at the samples that we have here and see which one we see a new species coming up. Here we have a selective breeding, which that means you choose the trait to produce new varieties of wheat, which is this wheat right here, with higher crop yield. Okay, the second one says evolution of different courtship behaviors in a separate population of the cricket Glarus rubens. The third one here says natural selection leading to increase in the frequency of darker individuals of Vistumbellaria, and selective feeding by koalas on eucalyptus species. So we have all these being described, and this is where students really don't understand, like, I'm sorry, but I don't know which one will bring me a speciation. So let's work on this. When we talk about speciation, we're making new species. So here's selective breeding to produce new varieties of wheat. So wheat, we're just having different types of mutations of wheat, right? So we're just choosing different wheats and we're putting them together to continue being wheat that will give me a better yield of crop. So you can see it still is the same wheat, but with better traits that come from these guys, but it's still the same. So you haven't made a new species, so it's not A. Here says the evolution of different courtship behaviors in a separate population of crickets Glarus rubens. So here we have different courtship behaviors of separate population. This part right here, separate population, is already a big important thing because we're talking about two different types of populations. So we have one population here and one population here, and somehow they have different ways of courtship. So that means these ones will only mingle with this, these ones will all mingle with each other. So let me put another way for you to understand. Imagine they are in this one island and you have two types, right? You have one type here and you have one type. So the black and green, they do not have courtship behaviors, or should I say they have different courtship behaviors. Courtship behaviors, that means they're trying to attract some other organism in order to mate. So whatever the black do does not align with what the green do. So they basically do not cross each other. So they eventually evolve. The black will stay on this way and the green will stay on this way. That means you're creating them two different species. So that is it possible? Yes. Next, here says natural selection are leading to an increase in the frequency of darker individuals of biston. This, you're not making a new species, you're just increasing the frequency. That's what it's saying. You're just increasing the amount, or should I say the frequency of one species. So this is not it. Selective feeding by koalas on elliptical species. This is just basically saying I'm going to eat more on this guy. So if I'm going to eat more on this guy, how am I going to make a new species? Just go ahead, eat more. It's like saying I just want to eat pizza. It doesn't mean I'm going to become something else than a human. I'm going to continue being a human, but I just want to eat pizza. So the only one that is close to speciation is B. The next one, the pectodactyl limb of mammals, birds, reptiles, amphibians Example, which kind of structure? So this, we already said it before. Remember, they have the same structure, so obviously it's homologous. Analogous would mean that they have different structure but the same function, which is not true. Vestigial, that means they lost organs. We don't talk about losing organs between reptiles, birds, and amphibians. And convergent, that means they come together as one. And they are not. See, the birds, the reptiles, and amphibians, they don't come together as one. That's what conversion is. They are literally as separated. So it's directioned this way and not this way. So the answer is A. And we come to the last question when it comes to 5.1. It says, which example provides evidence of evolution? See here, white wings of peppered moth turn black in the industrial. So they don't turn black. See, the whites don't turn into black moths, that's for sure. You have white and you have black. One dies, one survives. This has nothing to do with it. Antibiotic-resistant bacteria replace non-resistant bacteria over time. That is more possible. Why? Because you're switching from one to the other. So this is possible. Some Galapagos finches' beaks become smaller during dry years. So it's just saying that they became small. It's like my lips becoming smaller, but did I really change as a bird? No. And then here says polar bears are found in the warmer latitudes following the global warming. This is just they're changing their location, does not mean there's an evolution here. So usually students will have these two as more of their thoughts. Well, but they say, oh, but Galapagos finches, isn't that evolution because they're changing their beaks? But here it's just, it says during the dry years. So they're not really changing to another species, right? They're just, some years their finch gets smaller and some years they get bigger, but it's still the same species. This one, the antibiotic resistance replaced non-resistance. So that means you used to have a non-resistant bacteria, but then this disappeared and this is the new one. So this is showing how evidence went. You went from being a non-resistant to become resistant. So there's a full change. It's not like 1 year is dry and the next year is wet. You literally replace these guys from this. So the answer is B. And that's pretty much the examples of multiple choice for evolution. I hope it gives you an idea of what kind of questions that can come for 5.1.